Impulse and Momentum, video part 5. Let's do a problem. Let's solve a problem with a head-on collision and inelastic. So it is a head-on but inelastic collision. All right, so let's say you're on the highway and you're driving on the highway, and your car, including you and your car, the total mass is, let's say, 1,000 kilograms, and you're moving this way with a speed equal to 25 meters per second. Okay, and there's a car in front of you, another car. This will be car B, and its mass is, let's say, 1,200 kilograms, and their speed is VB1, that is, let's say 19 meters per second, a number less than your speed. So you're going to hit the guy, right? There's going to be a collision, and it's going to be an inelastic collision, you're told. So find I guess I need to give you the final speed of car A as well. Let's say VA2 is now 20. You slow down a little bit. So what will happen to the second car? What will be the speed of the second car, VB2? And also find how much kinetic energy is lost. Change in the kinetic energy. All right? So, what do we know? We have the momentum conservation, which is always true. MA VA1 plus MB VB1 will be equal to MA times VA2 plus MB times VB2. All right, so let's plug in those numbers and see what the new velocity for B is. So 1,000 kilograms times 25 meters per second plus 1,200 kilograms times 19 meters per second. That will be equal to 1,000 kilograms times, now the new velocity is 20 meters per second, plus 1,200 kilograms times this unknown, the B2. Okay, let's get rid of 2 zeros, divide by 100. So I'll have 250 here, plus 12 times 19, minus 200, divided by 12. So VB2 happens to be 23.2 or 23.1666, 23.17 meters per second. Okay, so as expected, you slow down and the car in front of you speeds up a little bit after the bumper-to-bumper accident. Now, what about the change in the kinetic energy? Let's calculate that now. The change in the kinetic energy, this will be a negative number because the final total kinetic energy will be less than the initial total kinetic energy. Some of this will be turned to heat or internal energy or even sound. All right, so the final total energy is 1/2 Let's go one by one. 1,000 kilograms. This is your mass times the new velocity, 20 meters per second. Square it, plus 1/2, 1,200 kilograms times, what is it, 23.17 meters per second square. Now subtract the initial total kinetic energy, 1,000 kilograms times 25 meters per second square minus 1/2, 1,200 kilograms times 19 meters per second square. All right, so 1,000 times 20 squared plus 1,200 times 23.17 squared minus 1,000 times 25 squared minus 1,200 times 19 squared divided by 2. This is negative 69.90 or 91 joules. All right, that's how much energy is lost, how much kinetic energy is lost. All right, how about a head-on and completely inelastic collision? How about that one? So this was head-on and inelastic. How about head-on and completely inelastic? Completely inelastic. Okay. Let's say these are toy cars now, and you put Velcro right in front of this car here, and the other part of the Velcro is on that side. Okay, so let's say this is, all right, 5 meters per second, and this is 3 meters per second. This is 0.5 kilograms, and this is 0.6 kilograms. All right, this is before the collision. After the collision, now these two become one. So A, B, this is MA, this is MB, this is VA1, and this is VB1. Both A and B move with the same speed now, an unknown speed. Let's call it VAB. All right, and this is the mass, MA plus MB. All right, which is 1.1 kilograms. So what is the new velocity? All right, again, momentum conservation, MA times VA1 plus MB times VB1 will be equal to MA plus MB times the new velocity, AB. It doesn't matter what you call it, but they share the same velocity. So that velocity VAB will be MA VA1 plus MB VB1 divided by MA plus MB. So we have here 0.5. VA1 is 5. Plus MB, which is 0.6 kilograms times 3 meters per second divided by 1.1. So that will be 3.9. 3.9 meters per seconds. Okay. All right. So my next example will be a glancing collision. All right. A glancing and elastic collision. Let me stop here.